4.3 looks at properties of logs. So since our calculators aren't capable of computing logs other than base 10 or base e, unless you have a higher tech calculator, we're going to learn how to use a change base formula that will allow us to enter any log into our calculator. So let a and b and x be positive real numbers such that a is not equal to 1 and b is not equal to 1. Then log base a of x can be converted into different bases using any of the following formulas. Base b meaning literally any base you want as long as it is a positive real number, base 10, which is our common base, which is one we would use to put in our calculator, and base e, which we know is the same thing as ln. So the base in your log becomes the number in your denominator, and then the x will become the number in your numerator, and you simply type it into your calculator like that. You would need to remember which one goes where there in order to use it successfully. Excuse me. So I'm going to look at this first example. It says log base 4 of 25. If I want to put this into my calculator, I would do log base 10 of 25 over log base 10 of 4. You'll notice on your calculator it doesn't say base 10, but it's the common log, so that's what it is, even if it doesn't say that. So I would type in log of 25 divided by log of 4. I'm going to put this one in the calculator so you guys can see, and then you guys can do the next one. So let me put this into the calculator. The way that this calculator has to be entered might be a little different than the way that yours works, but I'm going to type in 25 and press log. That gives me the log of 25, and I press divide. And I'm going to type in 4 and press log. That gives me log 4, and I press enter so it divides. And I'm just going to round to 3 decimal places here. You would be told what to round to, so I'm going to do 2.322. Okay, so the next one I would write as log of 12 divided by log of 2. So you can go ahead and put that into your calculator. The other common option for changing base is just to use the natural log. So I would use ln of 25 over ln of 4. I should still get the same answer. Log base 4 of 25 is going to be the same thing regardless of what base changing I use. So when I go to my calculator here, I'm going to type in ln of 25 divided by ln of 4, and I hope that I get the same answer as I did on the top. So let's check. Again, this might be a little different than what you have to type in, but I'm typing in 25 and pressing ln divided by parentheses 4 and pressing ln, that's ln of 4. I press enter, and I do in fact get 2.322. Okay, again, I leave you to do log base 2 of 12 using natural log. So ln of 12 divided by ln of 2. You put that into your calculator and get an answer. Up until this point, we've been able to solve logs by our common sense and our previous math knowledge. That's not the case anymore. No one would be able to tell you that 4 to the 2.322 power would give you 25, and that's where you're going to end up using your calculator, and these change base formulas are really helpful. There's also properties of logarithms that we're going to get into, and there's different properties. They're the same for log base a as they are for ln, just ln is written as ln as opposed to log base e. However, the rules still apply. So the first one you see is the product property. So it says that log base a, or ln of u times v on the inside of the log is equal to log base a of u plus log base a of v. Notice the same applies for the natural log. For quotient property, if you have two things divided, u divided by v inside a log, then you can actually do the subtraction, the difference of those two logs. So log base a of u minus log base a of v, the numerator minus the denominator. For the product property, order doesn't matter there. Addition, order doesn't matter because of the commutative property. For the power property, it says that if you have a log that has an exponent, you can bring the exponent outside of the log as a coefficient. So we're going to basically, they're almost like puzzles, play around with these three properties and rewrite logs in terms of different things. We can go both ways. So I can go from something where it's two logs being added together and turning them into a product, or I can go from a product and turning them into a sum. So we're going to do both directions, and we're going to look at all different properties. So let's look at this first example where it says write the logs in terms of ln of 2 and ln of 3. Well, I know that 6 is really 2 times 3. So this is really ln of 2 times 3. Based on the product property, that first one, I can rewrite this as ln of 2 plus ln of 3. If you were to go to your calculator right now and type in ln of 6 and get an answer, and then type in ln of 2 and ln of plus ln of 3, it would be the same answer. For b, I'm going to use what property here? I'm going to use the quotient property for b, and that tells me that I'm going to do ln of 2 minus ln of 27. However, it says ln of 2 and ln of 3, so this would really be ln of 2. I can write 27 in terms of 3 as 3 cubed, so I'll use ln of 2. Here I'm going to use the power property, and I'm going to bring that exponent out front and have ln of 3. So this exponent came out front as a coefficient because of the power property, and this would be my final answer here. I'm going to look at number 4. I'm going to use these properties to verify that this is the same. This is telling me the left side, negative log base 10 of 1 over 100, is in fact equal to log base 10 of 100, but I want to prove it. So I'm going to copy it down, and then I'm going to use the properties to rewrite the left side to make it match the right side. I want to work mostly on one side with proofs so that I don't get myself confused. I can have an endpoint that I'm working towards. So the first thing I notice is this coefficient. I'm going to make it into an exponent because that's one property I see right off the bat I can work with. So I have 1 over 100 to the negative 1 is equal to log base 10 of 100. I didn't touch the right side. A negative exponent means I basically dump it into the bottom. In this case, it's already in the denominator, so I end up moving it to the numerator. Log base 10 of 100 is log base 10 of 100. There are other ways to do this. There's not one way to do a proof. So if you had another way in mind, if you can make it match, by all means, you might be able to do it that way. I'm going to look at number 5. It says use properties to expand. That means it's already in, if I look back at my properties, it's something in this column right here. It's something on the, it's something on the left side of the equal sign, and I want to get it into something in the right side. So if I'm going to expand, I'm going from fewer logs to more logs. If I was going to condense, I would go the other way. I would go this way. So let me go back to my example here. Log base 4 of 5x to the third times y. So this is really multiplication going on. So I'm going to use the product property. So log base 4 of 5 plus log base 4 of x to the third plus log base 4 of y. If I'm making sure it's truly expanded, I should have no exponents. I shouldn't have any more products happening inside a log, and I shouldn't have any division happening inside a log. I'm good on products and division, but I do have an exponent. So I write this as log base 4 of 5 plus 3 times log base 4 of x plus log base 4 of y, and that is my final answer. I look at the next one. It's division, so I'm going to do ln of the square root of 3x minus 5 minus ln of 7. The square root is really the exponent of, and so I'm going to do ln 3x minus 5 to the 1/2 minus ln of 7, and so I can take the 1/2 and bring it out front. A temptation, or something I see that people do a lot, is they try to do something with this. There's no multiplication and there's no division going on here, so this cannot be expanded. That's as good as that gets. The fact that it already is subtraction in one log tells me that's all. If it was subtraction in 2 different logs and I was trying to condense, I could put it into division, but since I'm trying to expand and it's subtraction within one log, I leave it alone. That's my final answer. So this right here is the fully expanded log. Okay, I'm going to look at condensing logs. So if I have this, I'm basically making sure I don't have any coefficients, I don't have any addition of logs, I don't have any subtraction of logs, because those are all things that I can condense them into. So if I look at my properties, I'm going from this side here to this side here. Our first example says 1/2 log base 10 of x. So first thing I see, power property, that coefficient out front becomes log base 10 of x to the 1/2. It becomes an exponent. And the same thing happens over here. That 3 out front becomes an exponent. And the 1/2 again also became an exponent. Now since I have addition happening, I'm reversing basically the product property. I can put those two logs together because they have the same base into one log with multiplication. I'm not going to mess around with those exponents, and so that is my final answer. Again, even though I have addition happening here, it's happening in one log already. I can't condense that anymore, so that's as good as it gets, and that's my final answer here. For the next one, I am going to do what with the 2 out front of that first ln? Okay, I'm going to make it an exponent, so I do ln of x plus 2 squared minus ln of x. And since it's subtraction, I should recognize, I'm going to learn how to recognize anyways, that that's the quotient property. So this is ln of, my numerator is the first number, x plus 2 squared, and then my denominator is the second. And that's my final answer. I can't cancel those x's. This is really x plus 2 times x plus 2, so it's really x squared plus 4x plus 4. I can't cancel anything. So that's as good as it gets, and this is my final answer. This one's a little trickier. I'm going to condense the inside before I condense anything else. So inside I see it's two things being added together, so I'm going to multiply them. This actually is nice enough that I could simplify that inner log because it's just going to be x squared minus 4x. And then that 1/3 out front is a coefficient, and I'm going to turn it into a power. I will have log base 2 of x squared minus 4 all to the 1/3 power, which is really the cube root. If you didn't know that, you could have left it as the 1/3 power. It's essential that you learn these properties here and how to work with them in both directions. So if I was going to expand, I would be starting with these and I would move this way. So this would be expanding. And then if I was moving the other direction, that would be where I would condense. So if I was going to condense, it would be starting over here and going the other way. So this would be the direction I would go if I was going to condense logs. Think about condense, if everything's super condensed, it's smaller, there's less logs. If you're expanding, you're spreading out, there's more logs. So notice here there's one log, there's one log here, here there are two. You're expanding. As opposed to up here, there's 2 logs, and now there's only 1 if you were going in this direction. You do need to know these properties because we're going to get into solving different logs, and these properties are going to be essential for expanding and condensing.